Hi Calculus. Today we are going to work on making piecewise functions continuous. Okay, so number one, we have a piecewise function. Our first branch, 9 minus x squared. For all x is less than 2. Less than 2 is to the left of 2, so that is going to be our left function. And the second branch is k times x, and that's x is greater than 2. Greater than 2 is to the right of 2, so that is going to be our right function. So the first step is we find our left limit. Use correct calculus notation. So the limit as x approaches 2 with a little minus sign up there, our left function is 9 minus x squared. Now we have a limit problem. We can do direct substitution, so we plug in 2 for x. So we get 9 minus 2 squared, which is 9 minus 4, which is 5. That is our left limit. All right, now we do the right limit. Again, correct calculus notation. The limit as x approaches 2 with a little plus sign, our right function is k times x. It is a limit problem. We may do direct substitution, so we're plugging 2 in for x right there. So be careful, you're plugging 2 in for x. K represents a constant, a number. K is not a variable. All right, so we plug in 2 for x, so we get k times 2, and I'm just going to rewrite that as 2k. All right, so there's our right limit. The third step, we set them equal. In order for the limit to exist, at 2, the left and the right have to be the same. All right, so the third step, we set those equal. We set the left limit equal to the right limit. All right, and then we solve for k. So 2k is equal to 5. If we divide both sides by 2, we get k is equal to 5 over 2. Or 2.5. To check, go back and plug in 2.5 right here for k and graph the piecewise function on your calculator and go through the steps to check it. We will do that right now. Okay, here is how you use your calculator to check your work. All right, you graph the piecewise function. Here's my first branch. Here's my second branch. Okay, to check for a limit, you always start your table at the dividing point. So my dividing point here is 2. So I start my table at 2, and I go in very small increments. Now I go into the table and I check. As my x's are getting closer and closer to 2 from the left and the right, my y's from the left are getting closer and closer to 5, and my y's, from the left, my y's are getting closer and closer to 5, and my y's from the right are also getting closer and closer to 5. I can also check it in my table, or on the graph, Here's the graph. Here's my dividing point, 2. All right, if I put in my imaginary vertical line through 2 and I trace the graph, hey, I'm coming in right here at 5. From the right, I'm coming in at 5, right here. All right. Finally, we check for the definition of continuous. The first step, do we have a y value at 2? We absolutely do, right here. When x is 2, y is 5, so I have a y value. The second step, do we have a limit? We already tested that. We have a limit at 5. And are they the same? Yes, so absolutely. So, first step, definition of continuous, f of 2 exists. All right, the point 2,5 is on the graph. Step number 2, the limit as x approaches 2 of our function exists. It is equal to 5, and step number 3, they are the same. F of 2 is equal to the limit as x approaches 2 of f of x. We have continuous. Check your work, guys. Okay, number 2. My dividing point is 1. This is my first branch. To the left of 1, less than 1, that is my left function. And greater than 1 is to the right of 1, that is my right function. All right, so we get to work. First step, my left limit. Correct calculus notation. The limit as x approaches 1 with a little minus sign. My left function is 0.4x plus 1. That is a limit problem. When I do direct substitution, I get 0.4 times 1 plus 1, and that gives me 1.4. That is my left limit. Second step, I find my right limit. Correct calculus notation. The limit as x approaches 1 with a little plus sign. My right function is kx plus 2. I can do direct substitution. Remember, I am plugging in 1 for x, not for k. Be careful. Okay, so I have k times 1 plus 2, and that gives me k plus 2. That is my right limit. And now finally, my third step is we set the left equal to the right. 1.4 is equal to k plus 2. To solve for k, I would just subtract 2 from both sides. Good old algebra. So on the right, I'm left with k. 1.4 minus 2 is negative 0.6. And that is my k. And go ahead, make sure you check your work using your calculator. Okay, number 3. My dividing point is 3. Less than 3, that is my left function. And the second branch, greater than 3, that's to the right of 3, that is my right function. All right, step number 1, the left limit. Correct calculus notation required. The limit as x approaches 3 with a little minus sign. My left function, kx squared. I have a limit problem. Can I do direct substitution? Yes. I put 3 in for x, not k. So I have k times 3 squared, and that gives me 9k. That is my left limit. Second step, I find my right limit. Correct calculus notation. The limit as x approaches 3 with a little plus sign. My right function is kx minus 3. I have a limit problem. I can do direct substitution. I put 3 in for x. So I get k times 3 minus 3. And if I simplify that, I get 3k minus 3. Be careful. You cannot combine these. They are not like terms. This has a variable. This is just a constant. All right, third step, we set them equal. The left limit, 9k, is equal to the right limit, 3k minus 3. Okay, I need to get all my k's to one side of the equation, so I'm going to subtract 3k from both sides, and I'm going to bring the k's all over to the left. 9k minus 3k is 6k. On the right, I'm left with negative 3. Now to get k completely by itself, we divide both sides by 6. Good old algebra. These cancel. My k is equal to negative 3 over 6, or negative 1/2, or negative 0.5. A lot of options. There's k. Check your work. Use your calculator. Number 4. All right, now x is less than negative 1. That is my left function. X is greater than or equal to negative 1. Greater than is to the right. That is my right function. Okay, first step, left limit. Correct calculus notation. The limit as x approaches negative 1 from the left, a little minus sign. My left function is kx plus 5. I put negative 1 in for x. So I have k times negative 1 plus 5. When I simplify that, that gives me negative k plus 5, left limit. Second step, I find my right limit. Use correct calculus notation. The limit as x approaches 1 from the right. My right function is kx squared. I plug in, that's negative 1 there. Thank you, don't make that mistake. All right, I plug -1 in for x. Don't plug it in for k. Okay, so I get k times -1 squared. That gives me k times 1, which is just k. Okay, so that is my right limit. Third step, we set the left limit, -k plus 5, equal to the right limit, k. Now we get all the k's together. I'm going to bring the k's all to the right. So I'm going to add k to both sides. Plus k here, plus k here. So on the left, I'm left with 5. On the right, I'm left with 2k. And now I simply divide by 2 on both sides. So these cancel. K is equal to 5/2 or 2.5. All right, calculus. Hope that made sense. Let me know. Take care.